Hey, everybody, and welcome to another episode of JavaScript Jabber. This week on our panel, we have Christopher Beekler.
Hello from Providence, Rhode Island.
Christopher Denandi.
Hey, it's the vanilla JavaScript guy.
Amy Knight.
Hey, from Nashville.
We have a special guest panelist, and that's Steve Emmerich.
Howdy, it's the Dev from Naples, Florida.
I'm Charles Max Wood from devchat.tv, and this week we have a special guest, and that's Todd Gardner.
Hello, everyone, from Minnesota.
One of the things that I have as a goal for devchat.tv is to cover technologies that are up and coming, things that we're probably going to have to deal with on a more regular basis in the future. Some of these include AI, VR, and one of them is blockchain. So I reached out to one of the experts that I knew, Gregory McCubbin, and we pulled together a few other people, and we've started a podcast called Adventures in Blockchain. So if you're looking at blockchain as something that you may want to work in, something that you're curious about learning more about, or something that you just want to keep current on until you have the opportunity to make a career jump and go over and work in blockchain and crypto, then definitely check out Adventures in Blockchain. You can find it at adventuresinblockchain.io. Todd, we haven't had you on for a long time.
Yeah, I think it was 2015 or 2016 when I was on the show last.
I'll look it up. It was 2014.
Oh, dang.
Yeah, we had you on episode 138 talking about TrackJS.
What episode number are we on now?
380 something, I think.
Busy crew.
Yeah, we've been doing this for a long time. So yeah, do you want to just remind people who you are since it's been a while? A long while?
So my name is Todd Gardner. I am a software developer, startup founder, podcast speaker, conference speaker, comedy host. I do a bunch of stuff. Since we last talked, when I was on the show the first time, I had just started a small company called TrackJS, which does JavaScript error monitoring services. And over the last 6 years, I've built that up into a pretty successful thing. And we, check for errors in a lot of people's sites. I also started a little thing called Pub Conf, which is a comedy after party for developers. I host my own podcast with David Walsh called Script and Style. And I write JavaScript for small third-party plugins that go into other people's pages to capture things like errors or instrumentation or analytics and that sort of stuff.
Nice. And I was looking through the catalog on Front End Masters, and I have a long history with Mark Grabansky over there. And, we chat periodically. And I was like, man, there are some great courses in here. So I went to Michelle, who's our production manager, and I said, hey, get some of these authors on here. And your course on debugging really kind of caught my eye. So we made sure we got you on.
Yeah, thank you so much. I did a course with Mark. Mark's a good friend of mine. I did a debugging course with him about 2 years ago, maybe, when they had just moved into their new space. And Front End Masters is awesome. It is such a good format for both the trainer and the attendees or whatever, because it's not like a highly edited thing. You're talking to real people and you're getting real feedback about what people are confused by as you're doing the training. And it is such a pleasure to do.
Yeah, it seems like a great format. And then, people like me who can't make it to the actual presentation, I can watch it later. And you are still getting that live feedback.
Yeah. And I think it's really interesting, the difference between watching something that was delivered to real people versus watching something where it was just somebody talking into their screen alone in the dark. There's just a much more realness to how they're speaking to you. I think a lot of people can touch on.
Yeah. I mean, I've been to some of the ones where somebody's talking into their screen, and where they've done well, right? It feels like they're talking to me. And then they take questions through whatever medium they're using, and then it works. But a lot of people aren't good at it. And it's a lot more natural just to, you see faces in front of you. So I kind of want to get us into the topic, though, and talk a little bit about, and we'll put a link to your course, by the way, in the show notes. But I mean, my debugging is basically console.log, right? And then I have, something else in there that tells me,
Chuck. I am glad to hear I'm not the only one on that.
Oh,
yeah.
No.
Well,
yes,
then I have my, my bug reporting plugin on my website that says, and this thing blew up in production, which by the time it gets to production is probably a little too late, but That's me, right? So what am I doing wrong, Todd?
Well, so there's lots of levels here, right? Like there's all kinds of bugs that you catch like while you're developing stuff, right? And you're hacking on something and you're trying to get it out the door and you catch it in your local dev environment and you use your dev tools and you attach the debuggers and see everything and it's great. And then your tests will catch a whole nother round of bugs, right? You've probably written
tests. Joe's not here to break my kneecaps for saying that.
Hopefully you've written, some tests that focus on like what's going to break, and you've caught some more bugs. But no matter how good you've done on those first two, eventually, like there are some kind of bugs that really only get exposed in your production site. Stuff like, that third party has gone down, or somebody accessed over a crappy network, or we never tested the site using Internet Explorer 10, or whatever. All kinds of stuff happens in that production environment. And so that first step is knowing when those kind of things happen. Because if you've never done any client-side error reporting, you can think that like, the site has always worked for me. It must be 100% all of the time, right? And nobody has like an error-free site. Nobody who has ever like tracked that has had 100%, everything is great. Because people hit your site with all kinds of crazy plugins, with weird browsers, over bad networks. And so knowing that those things happen is like that first step. And then you can pull it back and debug it using whatever kind of tools you want. And honestly, console log is not that bad. Like, it's not the best tool in the world, but if you want to understand what's happening in an environment that you don't have interactivity with, like you can't just attach your debugger onto it. You're relying on a record of what happened. Having some intelligent logs in place about what steps have occurred in what order can really help you understand what happened in that remote session that happened in a different time. And so you can recreate it in your own local current environment and attach your debugger and step through it the way you want. But both tools have their place.
Yeah, that makes sense. I'm curious what everybody else does for debugging.
Literally console log.
Yeah, same here. That's pretty much my extent right now.
And like, I'll like console log bomb the crap out of my code with like console log 1, console log 2, console log 3, and like just litter them so I can see what's firing when, where things stop. It's very, like everything I do, it's very vanilla. It's not particularly sophisticated.
So for me, like even with vanilla JavaScript, if we're talking about front-end JavaScript, I think it's really important to like learn how to use the developer tools and putting debuggers, breakpoints, all that kind of stuff. And then also even like, to me, debugging is not always even just knowing your tools, but how to write your code so that debugging is easier. So like if you are passing anonymous functions around, and Kyle Simpson gets into this a lot with his JS course, but like naming those functions so that you have a stack trace. Because like even in the developer tools, if you put a breakpoint somewhere, you'll be able to see the stack trace leading up to that, and you'll be able to see like which functions and methods were called. I don't know. So all that kind of stuff is super important to me.
I'd be really curious about your perspectives here, Amy. I so rarely find doing things in the debugger easier or more informative than console log. And just kind of the errors that the browser surfaces naturally. I don't know, maybe I'm doing it wrong, but it's always felt like one of those the juice isn't worth the squeeze kind of things for me.
I guess, I can say like for me, one of the things that I really like about it is like putting breakpoints in place and kind of inspecting like the state of where things are at that point in time, because then I can go into my console and I can like, if I'm inspecting an object and like a common thing is, this object doesn't have a property that I'm expecting it to have, I can see like, does like the data structure of this object, is it what I expect it to be? And I can just like inspect that. I can hover over and see all of that, or I can like type it into my console and I can have access to like everything that the program has access to at that point in time. But there are cases where with JavaScript, it can get a little bit sticky sometimes. I think there's like race conditions and stuff like that with async code that console log. I will get different results when I log stuff out with console log versus using the debugger. But by and large, for the most part, like I will reach for debuggers and breakpoints and that kind of thing first. And if that doesn't work for me, then I go to console log.
Yeah, I have to chime in here. So I guess I'm level 1.5 because I do use the debugger in the dev tools in Chrome or Firefox periodically. But typically I start with console.log because, like Chris said, the error usually gives me enough information to know where to look and where the problem likely is. So I'll console.log it first because it's easy. And then if it's really kind of bending my brain, okay, everything looks the way that it's supposed to, then I'll go set a breakpoint and dig in. Okay, what's the state of the world right here? What's wrong right here? And then I can step through it. But that's by and far the exception for me. Usually it's just a console.log because I can figure it out in about 2 seconds. Oh, this value isn't what I expected, or this is undefined and it shouldn't be, or something like that. And then I can go back and figure out why.
I run into two issues with one with the debugger and one with console.log. I use both, although I will admit I use console.log a lot more than I use a debugger. I work in a ton of frameworks, particularly React, and sometimes using the debugger in combination with that. And there's a whole set of React debugging tools. It's a totally separate thing, but I just mean like the built-in Chrome debugger. When you're trying to do step-through debugging or similar, you can just get buried in the framework code instead of actually seeing what's happening with the code that you're writing, which can get really exhausting. So that's when I tend to just resort to just doing exactly what Chris Ferdinandi said, having like 9 million console logs that are all uniquely named so they're easy to find. The other issue I sometimes run into is on the server side when I'm working with Node, the terminal there is not great. So it's, you console log something and you get object, and you're like, all right, sweet. That's not very useful because I can't expand this. I can't do anything with it the way I can using the browser's console. So I'm certainly curious to hear if there are better solutions for that anybody has in terms of debugging on the server side as well.
So to handle the issue with framework code on the browser, both Chrome and Firefox support a feature called blackboxing, which is super helpful for dealing with that. So if you have that framework code, that React code or Angular or jQuery or whatever you're using, and you never really want to step through their code, then in the sources panel, you find those framework scripts. You find that React.js or jQuery.js or whatever, and you right-click on it, and one of the context menu options is to black box this script. And what it's going to do is that for your browser session, anytime that you are going to step into a function and you would be going through that, it's just going to automatically step you all the way through that script. And any error stack traces that it wants to print into the console is going to exclude or make partially transparent all of the frames of the stack trace that are that framework code. And so it can kind of hide a lot of that stuff from you for those sort of cases.
That's awesome. I should probably take a course in this stuff.
One other thing that I've seen, especially with the frameworks, I know that they have it for Vue and Angular because I've used them, but there are browser plugins that will help you debug that are aware of how those frameworks go together. And so it'll take you directly to the component or the service or the other code that you're working on that's having the trouble, and give you a little bit better view into, okay, you're dealing with this component. This is where it shows up on the screen. This is all the information that came into it, blah, 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 blah. And so now you can look at it and you can get a much better idea of what's going on in your framework code.
Oh, for sure. And I've used React dev tools to a degree in things like Redux Logger and various other stuff. There's a million options. It can sometimes be a little bit hard, honestly, to determine what the best set of options are for debugging, but I've had good luck with basically the official ones.
Yeah, one other thing that I run into, and maybe Todd can speak to this, but once I get the bug fixed, I usually just do a visual inspection and make sure that it works. But I'm not so good about making sure that I don't have a regression by writing a test. And I'm wondering, how important do you find that, Todd?
I think it depends. It's very contextual. If it's a bug that creeped all the way out into production, it's a mistake that kind of slipped through your own mental state and your own testing structure and your team's kind of review, and it's gotten all the way to production. And it is like a true bug. Like it's not like, somebody just never thought of that edge case, or it's something that like somebody purely missed, I would write a regression test to make sure you don't slip up that way again. And in fact, I might even, have a conversation with the team and be like, this is a kind of bug, a class of bug that we miss. We need to make sure that we're testing against this sort of thing. But, a lot of times it's just a dumb little mistake and it's just made it all the way through. And so tests aren't free. And if you're looking at this bug and you're looking at writing a regression test and you're like, oh, this test is, this is dumb. Like this is never going to fail ever again due to the situation. I wouldn't do it. I like to think about testing as it's a way of mitigating risk in your project. And so when you look at your project, at your system or whatever, you should understand like what are the parts of it that are most likely to fail? What are the parts of it that are going to break down? Is somebody going to change a contract on you? Is your actual logic really complex? Is there a state machine object operating? Understanding where the risk in your unique set of constraints are and focusing your testing effort on that is what I think pays the most returns.
Yeah, I'm thinking and I'm trying to figure out what's the next level of things that I should be doing in order to make my code easier to debug, or what techniques can I employ to make debugging more effective. I mean, you've heard the entire extent of my approach to, there's a bug.
Yeah.
So, what am I not doing? Or what is Amy not doing? There we go. Let's pick on Amy.
I think Amy actually made a great point earlier about designing your code at the beginning for debuggability. Building simpler systems, things with fewer levels of nesting, fewer generics, and naming things clearly, like giving functions proper names and passing around objects that more accurately represent your state can help you understand when the whole thing breaks down. You don't have to like dive back through a complex level of like this thing passed around a callback, which passed around a callback, which passed around a callback that was invoked from a context you didn't understand. If you just avoid some of those patterns, unless they're really necessary, debugging just becomes a lot simpler. If bugs are creeping up in your system and you're really struggling with how to understand what's happening and fix it, the problem probably isn't the bug itself, or the bug is a symptom. The system is more complex than it should be. Yeah.
Got it. So Amy's doing it right.
I mean, in general, yeah.
I kind of knew that. So one other thing that I'm running into with one of the things I'm working on is memory. So I have some code that I run, and lately I ran into a memory boundary where, the system just didn't allocate enough memory for it to get done what it needed to get done.
Did you crash Chrome?
No, actually it was it was the devchat.tv website. It's written in 11D, which then compiles to HTML. And the node VM only allocates a certain amount of memory. And so I was essentially blowing the top off of the heap. I couldn't allocate any more memory on the heap. And for those of you who aren't familiar, essentially the heap is just, so the node VM, when it starts up, it says, I need about this much memory so that I can do my stuff. And then it puts all the objects that it builds into that heap, and then it'll clean them up. That's what the garbage collection does. And yeah, apparently it wasn't getting cleaned up fast enough. And so it filled up the heap, and then it said, I don't have anywhere to put any more stuff. And when I deployed to Netlify, it was having the same problem, and Netlify basically only allocates, I think, 1.5 gigs of memory for your builds. And since we have, 4,000 plus pages for it to build, it was running out of memory. So how do you debug issues like that, where it's now not, hey, I died on this part of the code because I got something I didn't expect. Now it's, I'm running out of memory, or I'm running into some other invisible boundary that maybe, the network's not fast enough or something like that. So it's going to die in a different place every time.
Yeah. So there's a couple of different situations there, right? On the memory side of it, the two big paths that I see in running out of memory is, first, you're taking on a job that's too big, which sounds like what your case is you just are generating too many pages. You have this huge amount of work that needs to be done, and you can't fit all of the work into memory. The second is that there is a leak somewhere in your code, and you're holding on to a reference of something that maybe shouldn't be held on to. And they can be related to each other. But in the first case, in the case where you're trying to do too much work, a lot of times a developer will have tried to optimize the algorithm that they're using to do the work for efficiency. So I'm going to preload all of the different bits that I need so that I have them at hand in a way that I can look up the data really quick, and then I can build the thing that I need to build. By optimizing for that, you've de-optimized for memory utilization. You're putting everything into memory all at the same time. And so if you're hitting these sort of memory limits, you probably need to reapproach your design, your algorithm to how you're doing that work to pull things in, maybe not the fastest way, but the way that conserves memory, in the way that I'm going to pull this in when I need it, and then I'm going to throw it away and I'm going to get it again later, or I'm going to calculate it again later if I need it, which will make your algorithm slower. It might be slower to build all the pages. I don't really know a lot about the framework that you use to build the site, so I don't know if these are options. But in general, with the algorithm of how to build the page, maybe instead of calculating what the header markup looks like every time, calculating it once and storing it in memory, maybe you need to recalculate it every time so that you use less memory, but it might take longer to build out the whole site.
Yeah, I haven't been able to find an option like that, but that makes sense.
On the other side of it, which is much more common for client-side web applications, is a memory leak. And there's lots of great tooling built into the browsers now to help you understand and diagnose these things, but they are somewhat complicated. At the core of it, though, is that you are generating something expensive on the client that you're holding on to too long. So a great example is if you're doing client-side rendering, let's say you have a chat widget on your page. And to build up the chat widget, you are generating a bunch of markup, a bunch of elements that you are then going to put into the DOM. Well, as part of generating that, you've allocated all the memory to not only what is the state of all of those elements in their tree hierarchy within each other, but any events, any click handlers, any hover effects, any styles that go along with those elements are now all sitting in memory. Now, if that chat widget is then taken out of the page because they close that section of the UI, or you do a client-side navigation somewhere, unless you remember to fully drop every reference to that bit of markup, it's still going to be held in the memory of the browser. And by every reference, I mean you can't hold a pointer to some element. If you've attached a callback to part of it, and you still have that function that is a callback, you're holding on to that reference. If there's still other active listeners on that page, there is some way to get a reference back to those things. And so the whole chat tree of objects is still sitting in resident memory. In my front-end master's course, I use this example towards the end of the course where we debug a memory issue with ads. And essentially, I've loaded all of these high-resolution pictures as ads all over this fictional site that we built. But we're never actually we're never dropping any of our references to them because we're doing a bad job of attaching a click handler to them. And so even though none of the ads are visible, there's still these click handlers waiting for you to click on these ads that aren't even in the DOM anymore. And so that you can see the browser just collecting huge amounts of memory because there's all of these floating DOM elements that aren't visible.
Makes sense to me. Amy, I think you were trying to say something when I jumped in with my question.
No, I had already kind of talked about what we were saying about designing the code for debuggability and stuff like that.
This episode is sponsored by Sentry.io. Recently, I came across a great tool for tracking and monitoring problems in my apps. Then I asked them if they wanted to sponsor the show and allow me to share my experience with you. Sentry provides a terrific interface for keeping track of what's going on with my app. It also tracks releases so I can tell if what I deployed makes things better or worse. They give you full stack traces and as much information as possible about the situation when the error occurred to help you track down the errors. Plus, one thing I love, you can customize the context provided by Sentry. So, if you're looking for specific information about the request, you can provide it. It automatically scrubs passwords and secure information, and you can customize the scrubbing as well. Finally, it has a user feedback system built in that you can use to get information from your users. Oh, and I also love that they support open source to the point where they actually open source Sentry if you want to self-host it. Use the code DevChat at Sentry.io to get 2 months free on Sentry's small plan. That's code DevChat at Sentry.io.
So I have a question based on some of the errors that you're identifying that are happening sort of outside of your code control, or at least they're sort of errors that happen when the site is in production, like you said, if network connections aren't happening or that kind of thing. How do you mitigate those? Once you discover them, what are the best practices to move around them, to work around them, to try to make sure that they don't happen? How do you deal with them when they do happen? Just curious what your thoughts are on that.
When you're building your code, we're all taking on an external dependency of some kind, right? And I don't mean that like you've bundled these modules together into your JavaScript. I mean like you have your core JavaScript bundle that you're sending out to the web page. And then there's other things that you are expecting. There are third parties that are interacting on your page that you might have an expectation on. Things like the Facebook widget, or you're calling out into Stripe and you're expecting the Stripe JavaScript to have loaded, or you are calling into like an advertising platform, or you're loading a chat widget or something like that. A lot of our sites, we have these external dependencies that aren't part of our core bundle. And anytime there is that external dependency, there is a risk that that dependency failed. Maybe the Stripe JavaScript purely just didn't load. Maybe their CDN had a fault. Maybe the end user was in the elevator and they lost their data connection for a split second and that script failed to load. This is super common for individual assets on a web page to fail to load, even though your main JavaScript bundle hasn't. There was a metric that came out of a Google I/O talk a few years ago, and this was on like Android 5, an earlier version of Android, and they were saying that their internal metrics were saying that up to 3% of web pages visited on Android devices would have some partial load failure. Like some asset on that page, a CSS style sheet, a JavaScript file, an image, an iframe, something would not load correctly. And so we need to be defensive about that. If you're building like a credit card page and you're relying that the Stripe JavaScript file loaded externally from your own package, before you just start calling Stripe functions and doing your thing, you should check to see if it's there, because it might not be. Like window.stripe just might not have been defined correctly. So you should be defensive about that and be like, oh, this is an external dependency. I should start my code with if Stripe exists. And if it doesn't exist, you should have some intelligent fallback. Don't just leave the user stranded with a broken credit card form that'll never work. Like you should be like, oh, I'm in this error state. I should log it to my error logging service. And I should show them a fallback UI. Or maybe I should just reload the page and try again. Or I should show the user some sort of friendly messaging that says, hey, we're having a problem with our credit card form right now. Please try back, whatever. But something so that the user isn't just like stuck with a half broken site. Now, this can happen for a lot of other cases, right? So there's that third parties, but it could also be that the user themselves have kind of screwed with the page environment. And probably the most common path on this is with ad blockers. So ad blockers, depending on the setting, can be super aggressive with your site. Like it's not just ads that they might block. They could block, if you have the word advertisement as a class name on a div, some ad blocking list will just strip out that div from the markup. It'll just destroy it because you named something ad, or you named something sponsor, or you named something like one of their like track, or some other word that they flag. There are some super aggressive ad blocking lists out there. And so understanding what are the ad blockers that are most commonly hitting your page, like what are your users doing? Especially for developers. Developers tend to love ad blockers. So a lot of them use it, and a lot of them use like uBlock Origin, and a lot of them use like these different lists. And so if you're building a site for developers, you should really understand how your site is going to be crippled by those users' own technology, and maybe don't rely on it. So an example is, if you have like, say, a sign-up form on your webpage, let's say you have something, you want to sign up to be notified of a new podcast, or you want to sign up for a newsletter or whatever. as part of that sign-up process, it'd be super common for you to use your analytics service to just track an event. Like, I want to know how many times somebody, submitted this form. And so by doing that, you'll build a little form interceptor. And as part of that, you'll call out to Google Analytics or whatever your analytics provider of choice is. You'll call into your analytics provider and send an event that says, hey, this user just signed up. And then when the event gets completed, you'll go ahead and let the form complete. If the user comes in and they have an ad blocker installed that blocks your analytics platform, now your form is just broken. Now when they try and fill out the form, the analytics call just fails because Google Analytics isn't defined on the page. Or your analytics service there's no function there for anything to happen. And so if you're calling into a function that might get blocked, you really need to check if it's there and if it's functional first. And if it's not, maybe just have a backdoor. Maybe just say, all right, Google Analytics isn't defined. It might have been it failed to load. It might have been the user messed with it. We can't track our events, so just let the form submit. But being aware that these are external dependencies that might get changed out at runtime by the end user environment is a defensive practice that really should be more common on the web.
Yeah, I think that makes sense. When I'm working on my own site, closebrace.com, I run an ad blocker and a privacy blocker, even though I don't run ads or any major tracking scripts on the site. I do run Google Analytics, but that's it. Specifically because running those things allows me to see if something is breaking because of them. And then I can do it's not that different from, checking to make sure your DOM content is loaded before you start assigning event handlers. Because if you just go willy-nilly writing code that's expecting certain stuff to happen, and then it doesn't happen for people, that code breaks and it can cripple your entire site.
The end user in a production environment is going to have a different experience on your site than what you're going to have when you're all running it locally on a developer class machine on a fast internet connection. And so understanding that things load differently for different people, maybe intentionally due to their own extensions, is an important point to understand as a web developer.
I have a question. Do you find that it matters a great deal when you're developing for just the web versus like a mobile web or mobile application, and the errors specific to either of those? Do they differ a lot?
I think mobile applications are almost more troublesome than web applications. Well, all right, it depends on what you meant. If you're talking about a web application targeting mobile, but it's still a website. It's still like they open it with Chrome or Safari and they go to a URL. Those kind of things tend to have a lot of network problems, And you need to be probably more aware of network faults, of like images and CSS and JavaScript failing to load, and having adequate fallback plans. Preferably you've built a progressive web app and you've like cached a bunch of stuff locally so that the user can do stuff offline more effectively. Because mobile devices, they move around a lot. They're in low coverage spots. There's all kinds of like failures like that. If you're talking about things like React Native or Cordova or those sort of things where you've built a website, you built a JavaScript app, and then you've packaged it and delivered it, that I think has less of these connectivity problems because you've already taken all of your stuff and you've put it on their site now, or you put it on their device. Now, the exception to that is if you're still building your app in the same way, where you're calling into a Stripe script or a Twitter script or a whatever script that's being loaded, it's got the same potential to fail if it's wrapped in like a web view as it does if it was in a web page. Like, it probably didn't preload and cache those external service calls. And in many cases, it can't. And so you'll see those same kind of failures as long as it's still a JavaScript app calling out to a third-party dependency.
Makes a lot of sense.
It's interesting that you asked that, Steve, because lately I've been watching the analytics on devchat.tv just because, we're trying to grow the web traffic there, and I've been doing a lot of work on SEO. And I've been surprised that so many people are coming to the website on mobile devices. I think 40 to 50% of our traffic, depending on the day and what what we're looking at come off of mobile devices. And so it's not just there might be the odd person coming on their phone. It's half of our traffic is coming on the phone, so it has to work, or at least it has to work well enough for them to be able to get what they want. So is there anything we didn't bring up, Todd, that we should have thought about?
Well, one particular kind of problem that I've been thinking a lot about lately is debugging on a remote device. So I ran into this problem not that long ago, and I found that was really hard to solve. It was, you're building a web app, and you're trying to get it to work on phones, let's say. And for whatever reason, your app just doesn't work on one particular device. It works great for yours. It works great for anything that you personally have access to look at. But there's one particular customer, or there's one particular client, or there's some remote device where your site just doesn't work. How do you go about even understanding that, fixing that? What I would do at the time was I ship a bunch of logging statements out to a version of the code that they can access, maybe behind a query string or a particular URL. And I Ajax the logs back to myself so I can see what's going on. But it's a really slow feedback cycle to do that. I have to, build a new set of logs and deploy it somewhere, and then see some information, and then I can ask some questions, and I do it again. And I was telling that story to somebody, and they were telling me something very similar right back. They were building a web browser thing that would go in gas station pumps, that little kiosk computer that would show ads and relevant stuff like that. They were building a web site that was basically powering that. But there was always a handful of individual pumps somewhere else in the country that something weird was happening on, and they couldn't debug it. And so maybe 3-4 months ago, we built this little free tool that people could use to solve this particular thing called Remote.js. So it's at remotejs.com. And basically what it is it's a little hacked version of our TrackJS error monitoring script that's hooked up to basically funnel the data back across a WebSocket connection. And so you can attach this simplified debugger that we built in a browser live to another browser session somewhere else. And you can see all of the things that are happening in that remote log, what kind of network requests are happening, what the URL is that the user's on. You can get a screenshot of what they see, that sort of thing. But you can also execute commands. So you could ask what the state of your remote application is. You could see what's in the DOM. You could check what the status is of your state object, that sort of thing. And we do the whole thing by just this really thin WebSocket proxy layer that's basically just funneling data from the client to the debugger in real time. And we don't store anything. We just let it all go away. So we're able to run the whole thing on one server. We launched this thing maybe 5 weeks ago. And we've had 10,000 people debug sites with it so far, which is pretty fun. It's cool to see people using this. So this obviously wasn't quite the niche problem that I even thought it was.
That's actually a problem I've run into in the past too. When I used to work for the government, we had kiosk software we were making in Angular that we couldn't get into, and there's only one guy even allowed in the building. So that would have been extremely useful to try and figure out what exactly was wrong with those things.
Yeah, makes sense. All right. Well, Todd, why don't you give us kind of the elevator pitch for TrackJS, and then we'll go ahead and do some picks.
Sure. So the main thing that I work on most of my time is TrackJS, which is a JavaScript error monitoring service. And I'm sure most people have used one or are familiar with some options out there. But if you're not, essentially it gives you visibility into what's going on in your production client-side environment for all the reasons that we talked about today of understanding when a client hits your site with an ad blocker and something breaks, or understanding when some external third-party dependency is failing, or just understanding when a bug slips through to your production environment and you need to know. The thing that makes us different than maybe some of the other tools that you might have heard of is that what TrackJS focuses on is simplicity and of both our UI and how to use it. So we're not the most powerful tool available. We don't have an advanced query language. you can't like slice and dice your data in an infinite number of ways, but you'll never need a dedicated TrackJS engineer on your team to understand things. So many analytics tools are going to require a tremendous amount of time and effort and complexity to understand how they work and how to get your data out of them. TrackJS is focused that anybody can just come in, see what's going on. We expose the most obvious issues directly to you so you can get on with your day and move on to other things. It's totally free. It's totally free to get started with a trial, and we focus our service based on how busy your site is rather than how much data you send us. Because I don't ever want to like be profiting off of the misery of other developers by billing you because you let a bug slip into production and you sent me 10 million events.
Nice. Very cool. A couple of years ago, I put out a survey asking people what topics they wanted us to cover on devchat.tv, and I got 2 overwhelming responses. One was from the JavaScript community. They wanted a React show. And the other one was from the Ruby community, and they wanted an Elixir show. So we started both. The React show, though, is React Roundup. And every week, we bring in people from the React community, and we have conversations with them about React, about the community, about open source, about what goes into React, how to build React apps, and what's going on and changing in the React community. So if you're looking to keep current on the current React ecosystem and what's going on in React, you definitely need to be checking out React Roundup. You can find it at reactroundup.com. All right, well, let's go ahead and do some picks. Christopher, you want to start us off?
Hey, sure. So I've got a pick this week that has been useful to me lately because I've been working extensively with React and TypeScript. Very new to TypeScript. This was the first project that I worked extensively with it on. And having a cheat sheet in that sort of situation is really super valuable. So there's one on GitHub that's maintained by a bunch of folks. It's got relatively frequent additions, pull requests. It's got over 40 contributors to it. So I won't try to read out the GitHub URL, but just look for React-TypeScript-cheat sheet. And it starts you with the absolute basics and then moves on to some really advanced interface stuff, things that are frankly beyond my knowledge level at this point. So whatever level you're at in terms of working with React or TypeScript or combining the two, it's definitely a very useful thing to have open in a browser tab to reference.
All right. Chris, what are your picks?
Hey there. A couple for me this week. First, I wanted to highlight a couple of really interesting games some folks built just with vanilla JavaScript that I thought were really interesting. Hector Moreno Cervera built this really cool version of Pokemon Brawl, where you pick your Pokemon and they battle each other. I thought it was pretty neat. And also because I am an 80s baby, this hits all the nostalgia high points for me. But Andrea Mail, whose name I am almost certainly butchering, and I am so sorry, built a like a Space Invaders kind of game where you move your ship around and blast incoming alien craft and try and get high scores. It's just really, really neat and super well done. And I continue to be impressed by what people can do with just native browser code. Yeah, and then the only other thing I feel like I haven't mentioned in a while, but if you want to learn more about a more simple way to build things for the web, I have a week daily newsletter that I send out over at gomakethings.com.
Nice. Yeah, go check out Chris's newsletter. Amy.
Yep. So I have something, like we were talking at the beginning of the show, my boyfriend is starting to learn how to program, and he actually sent me some cool videos that he's been watching. And so I think like other new people might be interested in those. So one of them, and it's not just new people too, but because it's been a little while, I guess, since I've been out of this space, but it's a YouTube channel and the guy is a tech lead. But I guess he's a former tech lead at Google, and I was watching a couple of his videos, and they're exceptional. So I wish I would have stumbled upon this stuff when I was getting started. So I will link to that. And that's going to be it for me.
All right. Steve, what are your picks?
All right, so I've got 2. First one's Trello. I don't know if you guys have used that for like issue tracking, things like that. I try to use it daily to just like track home stuff for programming tasks, things like that. It's pretty cool. And then the second one is babushkas and grandmas to help you with your newborn. We just had our 3rd child, and both grandmas came down to help out with that. So that's super helpful. That's it for me.
Nice. I'm going to throw in a few picks. So I just finished the book Atomic Habits, and I'm pretty sure I've picked it on the show before, so I'm not going to go into it. But I'm really been digging that. And then I started getting up at 4 a.m. This is an Amy thing. She gets up at forever in the morning. And so I've been doing that. And it's interesting because, I get up and I go running and it's still it's dark outside, like dark. And there are two things that I really, really love about running at 4 a.m. One is that there's nobody else out there. There's no one on the trail. Yeah, I mean, I've gone even at 5, and by the time I'm running back home, because I go run for an hour and a half, and even if the run that my coach has given me isn't an hour and a half long, I'll just walk the rest of the time till I get a half hour, because I've been doing the 75 hard, and I want to make sure that I get 2 45-minute workouts in. I just do 1 hour and a half workout. When I'm walking back, a lot of times it's crowded. People have their dogs. And it's just, I kind of like just having the me time, the quality solitary time. And so, yeah, I kind of hate people sometimes. Yeah, so I'm going to pick getting up at 4 o'clock. But Atomic Habits talks about then stacking habits, right? So, and he also has another technique in there where it's, I'm going to do this thing at this time at this place. And so I'm going to get up and go running down the Jordan River Trail at 4 a.m. And then, when I get back, then I'm going to have a shower. Then I'm going to put together my power list, which is 5 things I need to get done today, and then I read scriptures with my family. And then I, go fix something around the house. And then, and so I stack all these habits on top of them. So anyway, just kind of putting all this stuff into action. It's been really, really terrific for me. And I've really enjoyed it. Didn't quite make it this morning because I woke up with a tension headache. But yesterday, things went really, really well. The only downside to that is that I tend not to go to bed early enough to to feel great getting up at 4 a.m. So I'm working on that. But anyway, yeah, I'm going to pick getting up at 4 a.m.
Woohoo! It's an addictive habit. I don't get up quite that early anymore because I've been staying up a little bit later, but it's so good. And like you said, I know for me, I was in a pattern a little bit. I'd get up at that time on the weekends and do my grocery shopping. And you're so much more productive because there's no lines, you can park close, there's no traffic. Anyways.
Yep. Todd, what are your picks?
Ooh, I get even more picks? Sweet. All right, I guess my first pick would be Pub Conf, which is this little fun show that I'm a part of. You can find details for that at pubconf.io. It's kind of taken on a life of its own, and there are events all over the world after different software conferences. And the idea is basically we rent a bar, we pick 10 speakers who are super entertaining. Sometimes they used to be actual comedians to do 5-minute funny talks about software development. And it brings together this unique cross-section of people because we're not focusing on individual technologies. We're just kind of making light of the whole situation. You get all kinds of people who would never normally talk at a software event because they'd be a part of different sub-communities. But they all show up for PubConf and we have a great time. There's 3 events coming up through the end of the year around the world. But you can find all of them out at pubconf.io.
Nice. That sounds like fun.
There'll be one in probably closest to everybody here. There'll be one in Minnesota next May probably, and one in Kansas City, Missouri in July probably.
Cool. All right. And if people want to see what you're working on these days, Todd, where do they go? Do they just follow you on Twitter or GitHub or email you or what?
Twitter's probably the best way because I haven't found anything better, even though Twitter's super angry lately. But Twitter is probably the best still. I'm at toddhgardner.com or at toddhgardner. You can also find me at my website. I'm todd.mn.
Nice. Very cool. Yeah, and I guess you have the Minnesota connection with Mark.
I do, yeah. Yeah, Mark and I both live in the Twin City area in Minnesota.
Awesome. I might wind up out there next year, so I'll let you know.
Yeah, holler at me if you come by.
All right. Well, I think that's everything we've got. So we'll go ahead and wrap this up, and we will be back at you next week.
Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.